Hey, what's up, everybody? I am going to work you through some examples involving the combination and transformation of random variables. So here are the formulas I'm going to use. These are the combination of random variables formulas, and then these are the linear transformation of random variable formulas. So we'll look at a couple examples below. All right, so let's start with number one. Suppose the average SAT math score is 625 and the standard deviation of SAT math is 90. So the average SAT verbal score is 590 and the standard deviation of SAT verbal is 100. The composite SAT score is determined by adding the math and verbal portions. What is the mean and standard deviation of the composite SAT score? All right, so what I'm going to start by doing is notating the numbers I have. So the mean of the math section is 625, and the standard deviation of the math is 90. We also have the mean of the verbal and standard deviation of the verbal. So the mean of the verbal is 590 with a standard deviation of 100. All right, basically what we're trying to figure out now is what is the composite mean and the composite standard deviation. So to think about each of those, so the composite mean, to get the composite score, you just add the verbal and the math sections. So what we're going to do to find so basically what we're going to have is C is going to equal M plus V. So mu sub C, if we think up to the formulas here, mu sub C is going to end up being mu sub M plus V. Well, now according to this formula up here, mu sub X plus Y is just mu sub X plus mu sub Y. So to figure out the composite score, I'm just going to do mu sub M plus mu sub V. And I have both of those numbers. That is 625 plus 590 ends up being 1315. So that's going to be your average composite SAT score. And again, that's pretty simple. We just add the two means together. All right, standard deviations don't quite work that way. So we can see that the standard deviation of a combination of two random variables isn't just mu sub X plus mu sub Y. What we have to do is we have to square each standard deviation first, add them together, then take the square root. So what this is going to be over here is going to be the square root of sigma M squared plus sigma V squared. So again, we're going to have to square each of those numbers. So we're going to have to do 90 squared, add that to 100 squared, and then we need to square root. So I'm going to put that all into my calculator. And this is going to end up being the square root of 18,100. And that gives you, and then we then want a square root of that, which is about 134.54. All right, so again, the typical composite SAT score is 1315, and then typically a student is going to score within about 134 points of that mean. All right, so that's question one. And again, that was a combination of random variables. All right, we're going to look now at number two. Mr. B loves to golf, but he's not very good. His average golf score is 105 with a standard deviation of 15. So remember, a low score is better in golf. His partner, Mr. A, averages 110 with a standard deviation of 5. So Mr. A is a little bit worse on average. His score is a little bit higher, but he's a little more consistent because his standard deviation is lower. What is the mean and standard deviation of the difference of Mr. B and Mr. A's score? B minus A. So basically, if we can figure out that difference, we can then figure out who was the better scorer and what was the difference in the number of strokes that they had. All right, so again, let's notate those numbers. So we're going to have mu sub B, sigma sub B. We're going to have mu sub A and sigma sub A. And I need to remind myself what those numbers are. So 105 and 115. 105 and 15 for the mean and standard deviation of A. And then this was 110 and 5. All right, and what we're trying to figure out is B minus A, right? So we're trying to combine those random variables, but this time we're using subtraction. So what we're trying to figure out is the mean of B minus A. And if we go back up to those formulas, if you're trying to find mu sub x minus y, you just do mu sub x minus mu sub y. So it would be mu sub b minus mu sub a. Again, which I have both of those values. So mu sub b minus mu sub a. And this ends up being 105 minus 110, which is -5. So what that tells me is that Mr. B's golf score is typically 5 strokes lower than Mr. A. So he usually wins by about 5 strokes. That's the typical value. Now what we need to do is figure out our standard deviation of B minus A. So if we go back up here to the formulas, the one thing I see here with my standard deviation formulas is I see a minus sign here, plus or minus, but I don't see a minus sign here, and that's intentional. So even if you're subtracting random variables, you're still going to add those squared standard deviations or add the variances and then square root. So we're going to still do that for our for this section here. So we're going to do the square root of sigma b squared plus sigma a squared. So it's the square root of 15 squared plus 5 squared. Again, I'm putting this into my calculator. So I'm trying to do the square root of 250. Okay, and then that ends up being about 15.811. All right, so that is the typical difference in those scores. So again, like I said before, typically Mr. B wins by about 8 strokes, but a typical round, that difference can be within 15 points above or below. So we can see that very often Mr. A will win because that standard deviation is so high, but typically Mr. B does win. All right, so that's number 2. All right, and the last one is number 3. The mean salary of employees at the Acme Corporation is $65,000. The standard deviation of salaries is $10,000. Employees can qualify for a $500 bonus and an incentive bonus of 10% of the employee's salary. If all employees qualify for both bonuses, calculate the mean and standard deviation of the employee's earnings. All right, so what I'm doing here now is I'm doing a linear transformation. So I have to think about this a little bit now. So I'm going to start by, again, notating what is given to me. So the mean salary is $65,000 with a standard deviation of $10,000. So I'm just going to use X in this case. So mu sub X is 65,000. Sigma sub X is 10,000. And what I'm trying to do is I'm trying to figure out how do those bonuses affect the salary. So remember, X is just the salary. But now what I want to do is I want to now apply those bonuses to that salary. So I'm going to start by looking at that incentive bonus. So the incentive bonus is a 10% bonus. So we need to increase X by 10%. And the way we do that is we multiply it by 1.1, right? So 100% would be the regular salary. If I want to increase it by 10%, I would add 0.1, so it would end up being 110%, or 1.1 as a decimal. And then if I applied the other bonus, the holiday bonus, that would just get added on to the top of that, added on to that 500. So what I am trying to now figure out is what is the average bonus, the average salary with the bonuses, and what is the standard deviation of that transformed random variable. So again, the transformation here is I'm doing multiplication and addition. So if we go back up to the formulas, so that's kind of what we're looking at. So in this case, the A is 500 and the B is 1.1. All right, so I'm now going to apply these formulas. So to the mean, what I need to do is I need to multiply the mean by B, and then I need to add A. And now notice for the standard deviation, in this formula, I don't see A. So that holiday bonus actually isn't going to change the spread of the salaries. It's not going to change how spread out those salaries are. It's just going to shift everybody's salary up 500, which again doesn't affect the standard deviation. All right, so let's go ahead and do these calculations. So to calculate this new mean, I just need to take 1.1 times that old mean of 65,000, and then I need to add 500 there. So if I do that, I end up with 72,000. So if everybody gets those two bonuses, then I am going to end up with a salary of $72,000. Now, the standard deviation, like I said, the only thing that affects the standard deviation is that multiplier. The additive bonus there, that holiday bonus, is not going to affect the standard deviation. So it's pretty easy to get the new standard deviation. All I have to do is multiply, the old standard deviation, not the mean, the old standard deviation of 10,000, and that ends up being 11,000. So again, what this tells me is that the new mean after the bonuses is 72,000 with a standard deviation of 11,000. All right, so again, that was an example of this linear transformation of a random variable. So number 1 and number 2 were combination of random variables. Number 1 was addition, number 2 was subtraction, and then this third example again was a linear transformation. All right, hopefully that helped. Thanks for watching.